C guarantees minimum sizes for its integer types, not exact ones. That sentence is the whole lesson, and it is the thing that separates C from almost every language written since. Look at the middle column, those are the minimums, the standard promises. A char is at least 8 bits, a short at least 16, an int at least 16, a long at least 32, a long at least 64. Now look at the column beside it, those are the sizes you will actually get on a typical 64-bit desktop. An int is 16 bits minimum, but 4 bytes everywhere you will realistically meet it. The gap between those two columns is where portability bugs live. Code that assumes an int is 4 bytes works fine on your laptop and on every machine you are likely to compile it on today, and then somebody builds it for an embedded target where int is 2 bytes, and their 60,000 item counter wraps round to 0. Know which column you are relying on. Every one of those types has an unsigned counterpart. Dropping the signed bit does two things. It removes the negative half of the range, and it doubles the positive half. A signed int tops out a little over 2.1 billion, an unsigned int reaches nearly 4.3 billion, which is why 4 billion fits on the first line and does not fit on the last one. Note the capital U on the literal. That suffix tells the compiler the constant itself is unsigned, and we will come back to literal suffixes later in the chapter. Unsigned char is worth singling out. It is the natural type for a raw byte of data because it is exactly 1 byte wide. It has no sign to complicate things. And every value from 0 to 255 means what it looks like it means. When you are reading a file format or a network packet, unsigned char is what you want. Use unsigned when the quantity genuinely cannot be negative and you need the extra range, but be aware that mixing signed and unsigned in a comparison is a real hazard. And there is a whole lesson on it later in this chapter. And here is the specific one that catches people. Long is 4 bytes on 64-bit Windows and 8 bytes on 64-bit Linux and Mac OS. Those two conventions even have names. Windows uses LLP64, where only long and pointers are 64 bits, and the Unixes use LP64, where long and pointers are both 64 bits. So any code that assumes size of long equals size of void star, that a long is big enough to hold a pointer, is correct on Linux and quietly wrong on Windows, where it throws away the top 4 bytes of every address. This is not a hypothetical. It is one of the most common reasons a Unix codebase does not build correctly the first time somebody ports it to Windows. The fix is not to memorize which platform does what. The fix is to stop asking long to be a specific width, and instead ask for a specific width by name, which is exactly what the next lesson is about.